بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so today we're going to have the last lecture about NumPy arrays. In the previous 3 lectures we introduced different features about NumPy arrays, including indexing, broadcasting, vectorization, and different aspects, memory layout as well. And today we will do an application of NumPy array. And one of the most famous applications of NumPy array is in scientific computing and in neural network. So I think all of you have heard about neural network, and today we're going to have a very brief introduction with an implementation of a very simple example from scratch. So you will implement a simple neural network from scratch just to give you an understanding about the basic concepts of NumPy array and how it's being used, how neural network leverages the features of NumPy array in improving scientific computing using vectorization, broadcasting, memory efficiency, and so on. So what is a neural network? This is just a basic definition. It's just a computational model inspired by human brains, but I don't see too much analogy with human brains, to be honest. So the structure, basically, it has a large or a deep neural network. It has several neurons. And you can think about neurons just as a computational module, very simple. And I'm going to show you what is this computational module. But here we have some terminologies we need just to know about them, the name of neuron. So here we have, this is one neuron, this is another neuron. You consider it as a black box. It will do some computation, linear computation and nonlinear computation, very simple. And with some reason, it's magic that it has very strong capabilities of learning and predictions. And now whatever things you see like improving or emerging in artificial intelligence and deep learning, it's basically neural networks. While before 2012, neural networks was not that the sophisticated technology in machine learning. There were other type of classical machine learning based on SVM and random forest decision trees and so on. But with the improvement of GPU and computational resources, because neural networks are greedy in terms of computing resources, it has made some substantial improvements as compared to existing traditional machine learning techniques, especially in computer vision. So neural network was the first technique that made and reduced the error of about 25%. And this was made a major improvement, and all the communities just turned out to work on neural network, and there has a lot of evolution like convolution neural network, recurrent neural network, transformers, which has led to what we know as large language models, ChatGPT, and these kind of things. And so we have a neuron, and a neuron is just composed of weight, which are coefficient. And biases, you know, the linear equation AX plus B. Everybody knows about it. So A is the weight, and B is called the bias. That's pretty much it. It's a linear equation, weight and bias. Okay? And it has an activation function. So AX plus B is a linear computation. Okay, but it turns out we can learn something if everything is linear. We need to have some kind of nonlinear, any kind of nonlinear function. Sigmoid is sophisticated one, softmax, ReLU, GLU, you know, so many things that are nonlinear, because this is how actually neural network work. So now we're going to use weight, biases, and activation functions just to define a very simple neural network. And we're going to apply it to a simple example. So usually when someone would like to buy a house, we try to make prediction or estimation of the pricing based on existing data. Okay, and it turns out that there is always a relationship, for example, between the service and the price, or some type of features that characterize the house and its price. So basically, if the house is located in a good area, usually the price is higher. When the service is bigger, the price is higher. When, for example, the age is bigger, the price probably is lower because it's old. So there are several factors that play an important role on deciding what the price is about. So this is, here we use a kind of linear regression, a simple model, but also neural network can be used to make such kind of predictions. Okay, so they learn from a data set. So what we will do now, we're going to have a simple model of a neural network. Very simple, and this is neural network. This is what it is about. It looks something like weird, but it's pretty much simple. Imagine that you have 2 features that will affect the price. And we talked that we can have a lot of data, but the features are those that will impact the result. In our case, what is the result? It's the price. So now I'm going to take the surface. If the surface is big, we're going to have higher price, and the age. So if the age is high, it has a tendency to decrease. Okay, in some of the cases, like old and traditional houses could maintain their prices, but usually it's not. And what it does in your network, it has just a few parameters. It has weights. So here we have only two input features, so we will have two weights. So basically what it does here, it will do W1 multiplied by the surface and W2 multiplied by the age. This is the linear computation. So we multiply the weights by the features. And these must be numbers at the end because we do computations. Okay, everything is number in neural network or in deep learning. Even if you don't have a number information, you have to convert it to number, like we convert words into vectors of numbers. So you have here a surface, you have here age. So W1 surface plus W2 age. This is and we add the bias. So the bias sometimes it's optional, but usually we add an additional vector that helps off learning as well, which is called the bias. So it's AX plus B equation, but here it's we have two-dimensional here because we have two features. It can be one-dimensional, two-dimensional, three-dimensional. If I use only the surface and the price, it will be only dimensional. W1 surface plus B equal to the price. But I want to make something multi-dimensional, two-dimensional, just to have an assessment. And of course, it's not sufficient to make linear computation because if everything is linear, you don't learn anything. You just make a projection in the space and you don't learn anything. So we need to have a nonlinear function. So I have chosen here sigmoid function, which is a simple one, 1 divided by 1 plus e exponential minus x. We will see it in a while, but it can be ReLU or it can be other nonlinear functions. So this is the equation. But now when we do algorithms, when we do deep learning, we need to have some math. So let's convert a little bit of abstraction. We can call surface as x1. We can call age as x2. Very simple. And x1 and x2 will be our vector x. Okay? So our vector x will just be x1 and x2, while x1 represents the surface. This is just a mathematical representation. But in our mind, you know that x represents the features. Okay? The input feature. Okay? Which is composed of the surface and also the age. And we have our weights. Of course, our weights, this is what will make the translation from the surface and age to the price. Okay, so here we have W1 and W2, as I already explained. And we have our bias term. Yes?
Doctor, the weights of the input, the weight of the line, the weight of the, what do you mean by weight?
Yes, this is what I mean by weight. So a neural network will have weights. In the beginning, they are random. So when they are random, what will happen? It will give you a random result. Now, if I provide more data, it will learn from this data and it will adjust the weights. So later on, it can make good predictions. So everything about learning is adjustment of the weights. Now we're going to implement this neural network. It will give us a wrong result because we're not going to train it. We will train it later on. It will give us a better result. But now we will focus only on the neural network itself. Let's assume that it has correct weights. Don't think about training right now, but we will do training later on. Imagine that we know the correct weights that will make the correct transformation. You have a question, Mir?
If a feature has a higher weight, it means it's more important, right?
Sorry?
If a feature, let's say surface, has higher weight, does it mean the feature...
No, there is no higher weight. The weights are learnable parameters. So they are going to adjust. Okay, so imagine, let's look at this example. Imagine you have these points. Now in the beginning, so what is W and B now? It's basically the slope plus this, the initial value at 0. What is the price at 0? Now, in the beginning, if W and B are completely random, you will find, for example, a line like this or a line like this. Yes. So this line, using linear regression, we're going to have this in machine learning. It will adjust the value of W and B in order to have the minimum error with respect to all the points. The average error, look now. Here, this distance is an error, this distance is an error. But we will try to adjust such that it's the closest to everything. And this is the learning process. This is something that we will see just later on. But now we're going to focus. Imagine that I know the correct W like here and the correct B. And I would like to build this model just to predict the price. assuming that everything is correct, okay? Which is not the case because usually we start from random values. And of course, okay, so here we're going to have the bias, and we will use our activation function, sigmoid. And finally, y, which is the price, will be just f, the sigmoid, wx. So here we will have matrix multiplication instead of taking value by value and so on, making for loop and making, no. We will use the vectorization and broadcasting. So here, w multiplied by x, it uses vectorization, and plus b, it uses broadcasting. Yes, it will broadcast over all the values. Yes?
The vector multiplication is going to either give a matrix or a scalar. But
No, at the end, yes, at the end it will give, now it will give a scalar because now we're predicting a single value.
But the sigmoid function takes only a scalar.
Sigmoid function is a vectorized function in Numpy. So it can take even a matrix, and it will be applied to all the values of the matrix.
So how we gonna get a scalar from the matrix?
In this particular example, we will make the inference for a scalar. So wx, it will give me scalar value plus b, another scalar value. But this is particular. But sigmoid in general, it's multidimensional. In Numpy, it's a vectorized sigmoid function. Okay? And you will see this in the implementation, so don't worry about it. But in this, now here we estimate the price. In some cases, you can estimate multiple values. So your output will be multidimensional. Okay? You can estimate multiple values. But here, this is something very simple. And my main focus is the utilization of Numpy. But of course, I'm explaining you the overall concept, so later on when you implement, you know what is an activation function, you know what is a weight. Just make an abstraction right now, and you'll learn this in more detail when you do a little bit of machine learning. Okay, so now we want to create a Python script that represents this neural network. We will create a class which is called neural network. So what are the attributes of the class? Let's think about the class. Let's design our class right now.
Weights,
It's characterized by the weights,
activation function,
okay, the activation function,
and bias.
and the bias. So these are the three main things. And this is what we want. Okay, so look now. Create a simple neural network for this simple use case. Okay, so in the beginning, we're going to create a class that is called simple neural network. And it will start by class initialization. So I think you already reviewed the object-oriented, okay? But I'm going to make a review about this, so don't worry about it. And we will have an init function which represents the constructor, and this will be used to create the attributes and initialize them, the weight and the bias. We will have to create a function for the activation, which is the sigmoid, and the forward pass. What is the forward pass? It's just making the prediction. We call it forward pass in the language of neural network. It can be also called predict. Okay? Given the input feature, I pass through a whole network and to find the result, which in our case, very simple case, is just the price. Okay. So now thinking about Numpy arrays, they have shape. What is our input shape? The most important thing when we design network is input shapes. Numpy, huh?
2 by 2.
The input shape is
1 by 2 by
2 elements, one, okay, 2 by 1. So it's just a feature vector, one dimensional feature vector. It's one dimensional. And the output is
price.
1 by 1.
1 by 1.
Okay, yes. So very simple. Okay, so that's pretty much it now. We're going to create a class which is called simple. You can write with me if you want, okay? So we can do that in parallel. Simple neural network. And the first thing we need to do is to create the constructor, which is the init function. And we will use self to refer to the current class or the current object. It's like this, the keyword this in Java. You remember the keyword this. It refers to the same class. So it's called self here. Okay. And now what we will define? Self dot weights. We can write W equal Equal what? Okay, so look now, how many values we have? Two. Okay, now usually in neural network we initialize to random values. But now let's say we're not going to train, so let's pick some values from, in our case, I'm going to initialize this. Of course, I need to import Numpy as MP. So I will create an array from static values. We can give it any number. Okay, and if I want to give equal weight to the surface, and let's assume that the surface and the edge, they have equal weights, I can put 0.5, 0.5. It's not correct, and okay, but that's a possibility. Or let's say I want to give a percentage, for example, more weight or more weight to the, what is the first one? The surface, and a little bit less weight to the edge. So we have surface and edge. So surface, the weight of surface is 0.6 and the weight of edge is 0. Okay. And of course, the weight, they represent some kind of the importance. But now we're just giving some values, random values from manually. But during the training, it will be calculated to optimize, to reduce the error, okay, as already mentioned. And what we should initialize also, self.b equal, we can give short value, I don't know, so, or maybe 1.2, it can be any value, okay. Here it's NP. Okay, so here we defined the attributes, okay, weights and biases. That's good. So what is the second requirement? The activation function. Okay. So we can make def sigmoid self and sorry, which lambda?
You can't use the lambda function.
No, here we define regular function. And sigmoid, what does it take? Look now at the sigmoid. So this is the expression of, I think I have an expression of sigmoid, no? What is it?
It's in the second slide. The one after this one, yeah.
What is?
Number 5.
Hmm?
Number 5.
Number 5.
Yeah,
Yeah, it's here. Yeah. Look, this is the expression 1 divided 1 plus e minus x. Okay, so very simple. Look now, before doing that, and it's important to think about the vectorization issue. Okay, so this is the. Now we have x in Python, by the way. Look now, if I take x equal to 5 and I make exp of x, it's math, import math, and math.exp. So we can find the value of exp. Now imagine that x is a list. Is a list of values. It doesn't work. It works only on real numbers. Even if you convert this, for example, to np or np.array. So exp in the math package, it's not vectorized. It only applies to scalars. It cannot be applied to vectors. Okay? However, if I do np.x, so this is the vectorized version. Okay? So it will broadcast, the exponential will broadcast on all the values of the vector. So we cannot use math.exp we need to use np.x. So np, it has some mean, standard deviation. It has all different vectorized type of operations. And we've seen this in the first lectures. So, yes.
X gives you e to the power of the...
Yes, yes. So here we're going to use x as a vector, and I will write as capital letter to mention a vector. And finally, it will return what? 1 over 1 plus np.exp. And you know why we use np? Okay, because we expect a vector. Okay, np.exp minus x. Okay. And I can try this, so I can do nn equal simple neuron. Okay. And we can define x as np array, or maybe x like this. And I can do nn dot sigmoid. It's always good to test. And I can find, okay, this is the sigmoid value. And you know sigmoid, it has a characteristic. It will always put the values below 1, 0 and 1. And this is part of the normalization of neural network that we need to make the training stable. It's a bit advanced concept, but it has a reason why to use sigmoid. And the nonlinear function, they have specific characteristics. And most of them, they put the value between 0 and 1. Because usually we want to standardize or normalize the data. Okay. So everything is fine now. But I don't know why it accepted x like this, because, yeah. And we can even specify the type here. For example, np.array. So this means we will impose the type to be np.array. So Python, yes, Python is not a typed language, but it's optional. Optionally, you can specify the type.
Can you run the...
Yes. It works. Okay, both are possible. You can impose the type. This is kind of data validation you need to impose. Because in some of the cases, the operations can apply on different types. But you say, no, I want this type to be applied only.
So,
okay.
P.exp means the p value, right? Why does it mean exponential? Exponential.
Yeah, exponential, yes. Yeah, this one is this expression.
So power is something else.
It's not the power, it's the E function. The E function.
You can't, there's no, you can't use power to the power, right? Because there's no, is there a constant E in Python?
Yeah, there is, yes, there is, you can use the power, there is power.
Free power.
Power, yeah.
Going into details.
Yeah, you can do that. And there are also vectorized versions as well. Okay, so we've done the sigmoid now. What's missing? Forward. Okay. And by the way, in PyTorch it's called forward also. So this is very similar to the implementation in PyTorch. Okay, so what we will do here in the forward? So what does it take forward first? Self and the vector x, and it will return. So basically we need to return the prediction or of the neural network. So this is because this is a very simple case, but forward pass it means you'll go through the whole network, because sometimes prediction it can miss some post-processing after that, but we will make it very simple, neural network. So how to calculate now the value using the biases? Okay, we have two parts. We can make it simply, okay, the linear output. What is our linear output here? What we will use? No, I talk about linear now. Look, I'm going to do wx plus b. How can I do that in Numpy? What is the function? Yesterday we did this function. It's MP dot, it's the dot product.
Oh, it's the dot product between W and
We have matrix multiplication. Yes, it's a matrix multiplication here. And we will put W and X. Okay, so we will put self.W, self.W, this is our weight, and the vector X. It's better to put W as capital. It's better, yes.
That's fine.
So usually capital, it means a matrix, and lower, it means a scalar. Okay, and can we use plus B here?
Just self.B.
Yeah, vectorization here. Okay, and broadcasting.
Self.B.
Yeah, and by the way, you can use this functionality. So plus self dot B. Okay, we can write it differently also, if you remember. Instead of MP dot, we can make at. So both are possible.
At means dot product.
Yeah, same. And then we will make the nonlinear output, or activated output. This is why we call it activation function. Is what? We apply sigmoid or self dot sigmoid, and this will be applied to the linear output. That's a neural network. Now you have a neural network that can do predictions. How is that? Okay. So I can use NN dot forward pass, and here I need to provide an input. So what is my input here? Is it clear so far? So I'm going to have a vector X. What is my vector X?
0.6, the area and
Yeah, so usually a feature, okay, we need to have features. So first feature is surface equal, okay, let's say 100 square meter. And the second one is age, let's say 6 years. So what will be my input X?
Surface and age.
Surface
2 by
and age.
1 by 2.
And here what I should put?
X.
Is this correct? Before I click. It's correct.
Doctor, the features are given by.
Problem is forward pass doesn't have a return.
Sorry?
Forward pass doesn't have a return.
Yeah, I need to return. Activated output. So it worked. But you know, if we want to make it right, in principle, if I look at print the type of X, it's a list. And here we need to have a NumPy array, because here NumPy, it will be converted to a NumPy array implicitly. But it's better here to be on the safe side always, is to make MP dot array, and okay. Now our input must be a NumPy array. Never input any kind of other data structures. So let's look at the shape. We can look shape.x, x shape. So it's 2, 1, and we have the output shape. So this will be our output. Y equal, and y dot shape will be 1. So this means it's a scalar. Okay, so we did everything here in the requirement. We did the forward pass, we computed the linear combination, and we implemented a vectorized version of the sigmoid function. Okay, now you will do this at home. You will improve the following neural network. Because now, look, we have an issue. We put very static value. So here it means this network will only work for two-dimensional input. Okay, now if you change the input, for example, to three-dimensional, I will add another value, 2.7. It will not work. The dimensions are not correct. So we want to generalize this. So instead of putting this here manually, we can define the input shape. Okay, you add arguments to define the input shape, and then when you create your weights, you can create a random value based on the input shape that you have. So I provide you some guidelines to continue working on this neural network and also creating a data set until later on we will do also the training. But now you have two extensions of this one. We want to generalize this so it can have hyperparameters like the input weight and initializing all the weights to random values. And then you will create a data set of what? Of course, we can bring a data set from the internet and work with it, but since I'm focusing on practicing on Numpy array, you will generate an artificial data set. So for example, you will say, I'm going to take the price, it's a random value between this value and this value. And I will take the surface, it's a random value between this one and this one. And you can make a relation. You can make like a linear relation between the price, the surface, and the age. And then later on, we can see whether our neural network is able to learn this linear relationship between the age and the price and the surface. Did you understand the objective? Okay, so we will do a linear relationship, and it can be even non-linear. You can do polynomial, you can do exponential, because the good thing in neural network, it's able to learn non-linear and very complex patterns. But of course, here we have only one neuron. Okay, so the learning will be limited, but still it can capture, we will see that it can capture some of the patterns from this weight matrix, the bias and also the the non-linear function that we use. واضح scope ولا؟ Okay.
So usually the weight and the biases are big data sets.
Yes. Now we talk about, for example, ChatGPT, it has 175 billion parameters. All are weights and biases. That's it. A neural network is just weight and biases and some other parameters, of course. Yeah, 175 billion.
Supercomputers are used to...
Yeah, it was trained on more than, I think, 10,000 GPUs to train GPT-3. Yeah. $5 million cost. Yes. Yeah, but you know, everything started from here. I mean, everything that you say, it started from this very basic. This is what we call perceptron. Okay? Yeah, this is the smallest neural network ever. Okay, and it can learn different patterns, very simple patterns, of course. But if we want to improve the learning, we can add 2 neurons, 3 neurons. Every neuron is going to learn different patterns, so the prediction could be accurate. And we will see some of this in the machine learning part. And of course, deep learning, you will be specialized. If you take deep learning course, it's basically on neural network from ground up.
Generative AI too.
Yes, generative AI, no, this is the advanced level. The good sequence: data science, machine learning, deep learning, generative AI. If you do it in this way, that's your data science track. Yeah. Okay, so I will send you this exercise. Try to complete at home, and the objective is to understand the operation of Numpy. So inshallah next week you will start with pandas. It's much simpler than Numpy and basically about visualization and descriptive statistics.